welcome everyone to today's presentation, Inventor discussing model states. Again, my name is Kindred Cooper and we have Keith Doran in the background running Q&A for us. So let's get right into it. First slide, I want to make sure everybody can hear me. Obviously, if you can, everything's okay, but if not, this slide is for those. But it does also introduce the Q&A panel that you can use during the presentation and towards the end to submit any questions. Real quick background on Hagerman and Company. We have offices covering coast to coast. Our field staff, such as myself and Keith, all of the field staff we have a combined experience of over 175 years working in engineering and CAD related industries. We've also got over 30 years of software sales and implementation experience for CAD software as well as data management software. So the agenda today, talking about model states. The benefit for model states is to build configurations within your piece parts and assemblies that show various design iterations, but also you could configure it to show steps during the manufacturing process. We're going to discuss model states and where they're located, how they're set up and used, how they integrate into an assembly bill of material and a drawing parts list. We're also going to do some comparison studies, model states versus design views versus iParts. That seems to be coming up a lot, comparing model states and iParts. And also some pointers of where and how model states cannot be used, which is a pretty big impact. So what is today? Little personal note here. It all relates to what we're going through. So the data set I'm using today is actually a bathroom vanity cabinet. I think it's something we can all relate to. There are some pieces in there that have a left hand versus a right hand configuration when it's the same board. I've gotten into woodworking over the past few years, and it's kind of interesting that today we're having this presentation. I didn't pick the date. I didn't decide on the date. Not really sure who did, but I know whoever picked this date had no knowledge of what today was related to me. Today would have been my father's 78th birthday, and he actually introduced me into woodworking when I was 5 years old. He started showing me things, and he showed me so many things there's no way I can remember it all. And of course I wish he was still here because I have a lot of questions about a lot of things. But I just found it interesting because when model states came out, I immediately dove into it using it for my woodworking because it applied so well to that left-hand, right-hand situation. And when I found out we were doing this webinar on his birthday, I thought, well, that's kind of poetic. So happy birthday, Dad. Let's jump into it. Model states, here's some of the benefits of them. They're introduced with Inventor 22. If you have 21 or prior, you do not have this capability, so it is part of the 2022 install. They replace levels of detail. Now, if you're familiar with levels of detail, they allow you to suppress components in an assembly. And one of the benefits of that is you get a reduced memory footprint for larger assemblies. So you're able to open up bigger assemblies because you have some pieces suppressed. Big thing there is like hardware, bolts and nuts. You know how many are in your assembly, but do you need to see all 500 bolts and nuts at the top level when you're trying to do other things? No, not necessarily. So you could suppress them and save that as a level of detail. Model states replace those. So any levels of detail that exist in pre-existing assemblies automatically get transferred into a model state when you open it up into Inventor 2022. Levels of detail in 22 are completely gone. There's no reference to them in the interface. Another model state benefit, you can have multiple design iterations within a single piece part file. Levels of detail did nothing with piece parts. It was only assemblies that it affected. Whereas in here, with piece parts, you can suppress features and save that suppressed state. We've been able to suppress features in the past for a long time, but we could not save that. We couldn't have it as a favorite, basically, suppress 4 or 5 features and come back to it with those suppressed and unsuppressed. Now we do. With one piece part file containing multiple design iterations, you no longer have the need to incorporate a derived component. We could do left hand and right hand before, but we would have to model one of them, one configuration, say the left hand. Then we would derive it into a new part file and mirror it to create the right hand. That's out the window. You don't have to worry about incorporating derived components anymore. Derived components is still there, but it's not required for this to work. Another benefit is model states allow the incorporation of unique iProperties, part number, description, material, things like that for that particular model state. And again, all of this is self-contained in one IPT. They are supported by the assembly bill of material, and it allows for simplification for simulation. If you go into Nastran, open up a piece part, you're going to run a simulation on it. You can exclude features in Nastran. You could right click on a fillet, you could exclude it, right click on a web or a rib, you could exclude that. There were some, and still are, some issues with trying to exclude multiple features that are related. And with model states, you can set that up ahead of time to go ahead and omit certain fillets, certain pockets, things like that, to again simplify your model in preparation for simulation. You can also use them to represent manufacturing steps. So you can start out with the rough cut material, raw material, if you will, what kind of machining process might be the first step, what other kind of machining process might be the second step, any kind of coating process, you could have a step for that and maybe even offset the faces to mimic the coating thickness. And all of the model states integration are supported with Excel. So just like you have an iPart factory, you can open that in Excel and get a much more friendly interface to edit the table. Model states is the same way. Some usage considerations. Do I use a view rep or a model state for a piece part? Well, view reps, a design view rep, it controls color of the part or the features. It controls view angle, so what orientation your view is set to that you're looking at that model. It also controls any kind of section cuts, graphical section cuts, using the section command on the view ribbon. So we're not talking about drawing section views, we're just talking about part and assembly section cuts in the model. Model states don't control any of that. They don't save or relate to any of that. Model states exist purely at the piece part level for feature suppression, to take an extrusion and a revolve and a loft and suppress those to either mimic a manufacturing step or reverse them to get a left-hand, right-hand situation. Another one that comes up is, well, do I use an iPart or a model state? And I'm hearing a lot of words around the internet and the groups that, oh, well, they're basically interchangeable. Ooh, no, they're not. iParts and model states, while they seem to give you the same benefits, and in many cases they do, there is a fundamental difference with how the end result works, and we'll look at that a little bit. iParts create separate piece part files from the factory. So if you've got an iPart with 10 configurations in it, and you place that iPart into an assembly, you pick one particular configuration, you now have the master iPart factory, but then you also have a separate IPT that is that one configuration. Model states do not do that. Everything is self-contained in one IPT. It can be good and it can also be bad. We'll look at those in a few minutes. So let's get right into it. As I said, we're going to be working on a bathroom vanity cabinet. This is one that I've actually started working on in my own wood shop. Got the panels glued up and ready to start cutting, and I ran into the issue of, well, trying to outline and differentiate the pieces this is a pretty simple design and layout. I'll do a different design on the doors. They don't exactly look like this, so I will have a left-hand and right-hand configuration. The knobs will be set lower, so we're not talking about a perfect mirror type situation. Same thing for the side panels. That's really the big heavy hitter in this. Is I've got 3 different configurations. Well, 2, but I could have more. I've got 2 configurations already set up to where I can have 1 shelf or 2 shelves and either 2 towel rods or 1 towel rod. And working with those multiple configurations, the side panels have to change to 1, accommodate for the dado cuts for the shelving, and 2, accommodate for the counterbores for the appropriate count of towel rods, whether it's 1 or 2. But they're the same piece. It's the same board. And what I had to do in the past is I had to model up 2 different IPTs. And then I had to remember, oh, if I change it one, I got to go over here and change it in this other one because I moved the towel rod up or back or widened up the dado cut, things like that. Biggest thing is the routed edge. On the right-hand panel, the routed edge is going to get rounded off on the outside, and on the left hand, it's going to be rounded off on the opposite side. But again, it was creating a little bit of a headache, nuisance really, with working with multiple piece part files before 22. When I look in the browser area, at the top of the browser in the assembly, you'll notice I have a model states folder listed up there. I also have the relationships for all the constraints, and then I have representations. Now, in the past, the representations folder had 3 listings. It had the view rep, that's your design view rep. Then it had position reps, and it had levels of detail. And you will notice there are no levels of detail in this assembly. This was started in 2021 and saved originally in 2021. As soon as I open in 22, that level of detail folder is gone. So any levels of detail I may have had get automatically moved to the model states folder and translated into that kind of technology. Creating new model states works just like creating a view rep or a level of detail. You right click on the model state folder, you tell it new, and it gives you a generic model state 1, model state 2, so on and so forth. You can rename these model states to whatever you see fit. What I'm actually going to do, well, even before that, with any file that you have, you get a master model state. The master cannot be deleted, it cannot be renamed, it cannot be modified. It basically just shows everything. You can suppress components and save that as part of the master model state, or you can create your own. So right here, I've got a 2 shelf, 2 towel rod model state configured. And you'll notice right now we're looking at 2 shelves and 3 towel rods. So when I double click on this to activate it, you'll notice I have 2 shelves, 2 towel rods. The towels got taken out because I suppressed them. If I switch over to the 1 shelf, 1 towel rod, 1 shelf goes away, the 2 towel rods disappear, and I get 1 towel rod showing in the center. And you'll notice on these side panels, I don't have the other 2 counterboard holes. I don't have those present in there. And the reason is this assembly level model state is associated with those piece part model states. So if I look down here in the tree, there's one of the cabinet sides. Let's look at the other one above it. That's the shelf, that one. So right here, we're looking at the different model states that are pre-built or that I've already got built in this side piece. And I've associated this assembly level model state to use that piece part level model state. So how do we really work with these? Well, let's start from the scratch. Let's go and open the side panel. And this is basically the finished product that I'm going to use. I've got my notch out cuts, I've got my profile cut, and I have both of the fillets for the left hand and the right hand. Now, in the past, I would have a piece part for the left, a piece part for the right, and they would each only have 1 fillet applied to the appropriate side. With 22, I can now incorporate a model state. What I've done to kind of prepare for this to make life a little bit easier going forward is I have gone in and named out a few of the critical dimensions, things that I need to control and adjust. And what you want to be careful of is you want to go ahead and design your piece part, get everything there, all of the features, all of the sketches, get all the dimensions where they need to be, and then start creating your configurations. What you want to watch out for is model states allow you to have not just different features turned on and off, but also different values for the parameters. So you could have one particular model state where the board width is 6.5, and another one where it's 5.5, and another one where it's 4.5, and they're all contained in this same IPT. It's just a different model state. So what I'm actually going to do is I'm going to set this up to mimic the cut processes I'm going to go through. So first and foremost, I'm going to start out by creating a new model state, and I'm going to rename this to finish milled board size. So this is what I'm going to start with. This is going to be my milled down, planed down board, but there's not going to be any cuts on it. So I've got to get rid of all of this detail that's out here in the model. The way I do that is with my finish milled board size model state active. I'm going to come down into the tree, and I'm simply going to suppress what I don't need to reflect this model state. So I'm actually going to suppress the 2 extrusions and the 2 fillets. Right click on them, suppress those features, they're gone. I'm now looking at that starting milled board, ready to start cutting out things. I can go back to the master, everything comes back on. I can go back to the finish model state, and those items are disappeared. If you are using this to mimic machine steps or cutting steps or manufacturing steps, here's a tip. Don't have master active and then create a new model state. The reason is whatever model state you have active, it's going to use that current suppression state as your new model state. So it's just more work to have to go through there and suppress other things. Not a big deal unless you've got a giant model. If you're using the model states in succession with each other, then I've got my finished milled already set up. I'll right click, go to a new model state. I'm going to rename this one, and I'm just going to call it first cut, or actually I'll call it notch cut. Notch cut, and it uses that finished board model state, so everything's suppressed. Now all I got to do is unsuppress what I need for this model state. So I'll right click on that extrusion, unsuppress feature. There's my notch out cut. I'm going to make another one. Again, the notch cut is active, so it's going to use that as the basis for the next one. Tell it new, rename this one, and I'll call it profile contour cut. And that's the next extrusion that I'll unsuppress to get the curved contours down at the bottom. So the last, well, no, not really the last thing if I'm going to put in the drilled holes for the towel rods, but the next step would be the routed edge. So depending on where I'm going with this, which side am I using, the left hand or the right hand? I am going to create another new model state, and I'll call this left side routed edge. So in the tree, I have 2 different fillets. They're both the same size. They're both linked to the same parameter, but one is applied to the left edge, one is applied to the right edge. So what I'll do is I'll just unsuppress the fillet for the left edge. I'll make another new model state. This one is going to be the right side routed edge. Now for this one, I'm basically going to flip which fillet is suppressed. So the fillet for the left edge will get suppressed, and the fillet for the right edge will get unsuppressed. So now I've got model states that represent each side that I'm going to use. And again, we're staying in the same piece part. We're not leaving this part file at all. one thing that model states does not do is if I try to use this sketch and I try to use the hole command to drill out some holes, with model states, they control the existence of a feature and the parameters of the feature and the sketch. They do not control the options of the feature. That's one key thing to take away from this. So I may have holes drilled going one direction, and you may think, okay, we'll just save that as a model state, make another model state and flip the direction. That won't work. It doesn't allow you to control that feature direction. So for this to work out the way I need, I'm going to have actually 6 drilled hole features to get all the combinations I want. So for this, I'm just going to deselect the ones that I don't need right now, starting with the top one, assigning it to the appropriate diameter. And then I'm just going to share that sketch to make it available and continue on making 5 subsequent drilled hole features. Picked the wrong thing. So there's another one, the third one. And then lastly, I'll do it again, but now I'm going to flip the direction. So all 3 of those were drilled coming out in, say, -Z. The next ones I'm going to drill and they're going to come out in the positive Z direction. So I'll pick the same center points and simply flip the direction. Take that direction for the top one. Where is he at? He's in here somewhere. There's that one. There he is. Make sure I got the right direction going. Perfect. And select the bottom one. So at this point, I actually have a hole going all the way through. But when I save this as a left-sided drill or a right-sided drill, I'm going to suppress the holes that I don't need for that configuration. So if we're looking at the right side board, so that means the towel rod is going to be coming from the internal flat face and coming across the screen here. That means I need to get rid of these on the outside. So I'll turn off visibility of the sketch to clean it up. And I'll find the appropriate holes. So it's the first 3 ones. So I'm going to make a brand new model state for that. And we'll call this finished right side. I'll just say finished right side. Now I'm not going to worry about boring you with all the configurations, but we could have a configuration of 1 hole right side, 2 holes right side, and 3 holes right side. For this, I'm just going to suppress hole 22, 23, and 24. Right click, oops. Suppress that one, and that one. Okay. Now I can flip this to do the left-hand side. So go ahead and save this. Right click, create another new one. So it keeps all the same suppression state from the previous one, which was the right-hand side. And I'll do the same here, finished.
Kendrick, shouldn't you switch to the left side routed edge first and then make a new one?
No, you can. It just, when you do that, you'll have to suppress more features. So it's just a little bit of extra work, but not a big deal. So looking at the right side, we've got the drilled holes or countersunk holes on the outside. They're turned off. That's how it should be. If I switch to the left side, then I can unsuppress the 3 holes on the outside, suppress the 3 holes on the inside of this, and then flip my fillets. And this is what Keith was talking about. I could have went to the other one and I wouldn't have to come over here and unsuppress this fillet and suppress the other fillet. It would already have the appropriate fillet suppression. So that would save some time, but I at least wanted to show you the flexibility that you could still go in and modify and continue unsuppressing other features. So now we've got our 2 configurations. We've got the finished right side, holes drilled on the inside on the flat with the rounded edge on the outside. Finished left, again, holes drilled on the inside on the flat with a routed edge on the opposite side. Now, I could run with this and it'd be perfectly fine. you have the option of tweaking the information even more, such as if I wanted to, on each one of these model states, I could right click and configure iProperties per model state. So for example, if I go up here to the master and I look at the iProperties for the master, you'll notice the part number is called cabinet side. There's no description or stock number or anything like that. If I go to the finished left side configuration, right click and do an iProperties on that configuration, right now it has the same information, but I can type in whatever I want. So we'll call it left side finished product. And I'm going to copy that. Stock is coming from finish milled board size. Go and do the same thing to the right hand side. iProperties on that, change the part number, change to the appropriate name, and stock number. Okay, so now when I go back to the master and I look at the iProperties, you'll notice the part number still shows cabinet side and there's no stock number. If I go to the finished left side model state and look at the iProperties for that, it has its own unique set of metadata associated with this. This is going to be used in the assembly bill of material. Same thing goes for the right side. I did the iProperties override on that. Same thing here. It's got its own part number and stock number information. When I'm ready to insert this into an assembly, just start with an empty assembly. And we're going to place the cabinet side, and I'll just go ahead and constrain it to the origin, make it easy. And I'll put in 2 of them. Over in the tree, you'll notice under each one of them, we have access to that model state folder. Now again, it's the same piece part, right? So we're not dealing with an iPart factory in this workflow. What we're dealing with is one piece part that has all of the design configurations we need. So first step I need to do in the assembly, get all of my pieces in here, get them constrained how you need them. And if you need to change configurations, go ahead, but you want to set up your different model state configurations in the assembly as well. So this might be a 2-shelf, 1-cat towel rod configuration, whatever we're going to call it. I'll just take the generic name of model state 1 for now. With model state 1 active for the assembly, I want it to use on the right-hand side, it's going to use that right-hand board. And on the left-hand side, I need to change the model state for that piece part. So down here in the tree, I'll just choose the finished left side configuration. As you see, the geometry adjusts, showing the different configurations. And again, it relates back to the same piece part. If I switch back to the master, it goes back to what originally I had both of them as the same configuration. Switch to model state 1, they show up that way. In the assembly bill of materials, if I enable the structured, you'll notice the part number field. It's pulling those individual iProperty pieces of metadata from those model states. So even though they're coming from the same exact IPT, it's not pulling the master IPT part number. It's pulling the model state part number from the iProperty overrides. So this is huge. This really helps organize the bill of material based on what you're using. Now, there is a little bit of a gotcha with this. Let's go look at the main assembly here and go ahead and look at we'll go ahead and do the 1-shelf, 1-towel rod. Now, this is a particular model state that I have. Look in the tree very carefully. You'll see there's 2 towel rods that are suppressed. There's the towel that I had showing up There's also 2 other smaller towels and that shelf. Those items are suppressed. Now, anytime you go to suppress a component, let's say I want to suppress this door. If I right click on it and I choose suppress, I get this warning. And it basically tells me, hey, here's an important note. When you suppress a component, they no longer participate in the bill of material, but the item is still there. It's just counted as 0. So when I come in here and I look at my assembly bill, you'll notice there's the cabinet front, 2, 1, 2, get down here, and there's the first. There's one of the towels, and you'll notice the quantity is 0 because it's suppressed. It's still showing up. And this is one difference that levels of detail did not do. If you suppressed a component with a level of detail, the component still showed up in the bill of material because levels of detail were intended as a memory management system when we were still working in 32-bit and a 3 gig RAM limit. That's when they were introduced to help us manage those larger assemblies. Nowadays, there's not so much need for them. So we get additional benefit to go in and suppress components, counting them as 0. That's fine. We can fix that in the drawing. So if I come out here and I make a new drawing and drop down a view of that. Oh wait, that was the piece part. I need the assembly. There we go. So let's just make half scale view, shade it. All right, so you'll notice some components in here have been suppressed. Got one of the doors that's not showing up, one of the shelves, and 2 of the towel rods. So I'm just going to do a custom view so we can see all that a little bit better. All right, so now if I come over here to the annotate tab, annotate ribbon tab, and I invoke the parts list, and I select that view, or I go and select the assembly, doesn't matter. I'm looking at the structured bill of material display. And let me back up because there's one other field I meant to show. Right there, you have under the file path for what file you're pulling this parts list from, you have what model states you want to represent in the parts list. So you can represent what's being shown, or you can represent something entirely different. Obviously, I'm going to represent what's being shown in the drawing view. When I place that parts list, zoom in real close, you'll notice right there you've got 1 door. Well, we need 2 doors, but it's only counting 1 of them. So when it gets suppressed, it doesn't count that item. And if you suppress it entirely out, it counts it as 0. So what I might need to do here is go back to the 2 door so it shows, or the 2 shelf model state, so it shows all of the components, but I still have these 0 components I've got to deal with. The easiest way to take these out of the parts list is to edit the parts list, locate those particular rows that you have, right click on them, and uncheck visibility. They're still going to show in the parts list editor, but now they won't show in the drawing display of the parts list. And again, you'll notice the part number field or part number column. It's pulling that information from that model state from the iProperties metadata for that model state. So populating that throughout is a huge benefit. So then the question comes up of, okay, so how is this any different than iParts and iAssemblies? Well, let's look at a kind of an example for that. So I've got a 1/2 inch, I think it's a 1 inch long, maybe 1.5 inch long, 1.5 inch long bolt, 1/2 inch heavy hex. Now, if I look at this very carefully, in my parameters, I've got this mapped out. I've got the parameters named like I'm going to make an iPart. I've got the features named to help me, differentiate what is what a little better. And nothing stops me from coming over here and saying create iPart. I still get the iPart table, can put in as many factory members as I wish, access to property information, suppression of features, iFeatures, iMates, things like that. Can still do that. Or using model states, I can do much of the same. To make life a little easier, I might even come in and put in multiple value selection for some of these properties. So say the bolt length, maybe I make that one a multi-value list on the other screen, and we'll go with 1 3/4, 2, 2 1/4, 2 1/2, up to 3. Now add those as the options. So now very quickly, just using the parameter manager, I can switch from a 1 1/2 inch long bolt to a 2 inch long bolt. And you see the model updates, of course. Could also do that with the thread length. I could make that multi-value as well. So maybe 1 1/4, 1 1/2, and I'll just stop there. Same deal here. Why is it not? Oh, I've already got them. Didn't take it. Try again. There we go. All right, so I've got 2 parameters set as a multi-value. The model states can use these multi-value setups. As it stands, I only have the one master model state. So I'll just create one, and we'll call this one 1.5 inch length. And I'll make another one, and I'll call it 2 inch length. All right, so with the 2 inch length model state active, what I can do is go into the property manager, and I can say, well, let's lengthen this to 2 inches overall bolt length or overall shaft length, and let's take the threaded length up to 1.5 inches. Say done. As you see, the model updates. When I switch back to the other model state, the configuration updates to reflect those. As always, I can come in here to iProperties, input the part number field, stock number, things of that nature, and it's unique for that model state. So how is this any different than iParts? Well, depending on your workflow and your need, this may work perfectly for you to have one piece part that has all of the different configurations in it with all of the appropriate iProperty information in it, because we can pull every bit of this into the assembly bill or into the drawing views. With an iPart, what it would do is we would have an iPart factory, and then as you place individual members, you would have a standalone piece part for that member configuration. So with iParts, if you needed to change, I don't know, say the thread length by 1/8 of an inch, well, now you have to change it in the factory and the subsequent piece parts that you've made. With model states, you don't have to do that. You come into the one interface and it changes them for all of them using that parameter. Let's see. Let's get into some gotchas and do's and don'ts. So the gotchas with the piece parts. As I mentioned, feature direction is not controlled by a model state. So if you have, start a new piece part real quick. And if we have an extruded box, whatever size, extrude in the positive Z, and I'll go ahead and make a model state, and I will call that positive Z extrude. Now I'm going to flip it. I want to go the other way. So I'm going to make another new model state. I'll call this negative Z extrude. And you might think, okay, well, I can just come down here to extrusion 1 and flip the direction. That doesn't get captured by the model state, because when I go back to the positive Z extrude, you'll notice the direction doesn't change. So if you need a configuration like this, the best way to handle it is to take that source sketch, share it, and on your alternate configuration, suppress this extrusion and create another extrusion. So I need to just actually flip those. There we go. So I now have 2 extrusions in my tree. Get rid of the sketch. So I have the positive Z extrusion under the positive Z model state. If I switch to the negative Z model state, you'll notice the direction changes. That's the case for every one of these features, whether it's a sweep, loft, a revolve. the coil command, you'll have to create a separate feature to change that direction. Same thing I had to do in order to get the drilled holes of the end of the cabinet to go the appropriate direction. I had to create an entirely separate feature because I can't tell the hole command go the other way with a new model state. That's not what it's intended for. Looking at sketch features and parameters, they can be unique per model state. So that's why I say go ahead and get your configuration built with all your sketches, everything named if you want to name it, but have all of your sketch dimensions and your feature dimensions set to what you need them to be. If it needs to be 1.5 inches, set it to 1.5 inches. Once you have all of your sizes set where they need to be, then you can start creating model states. If you don't do that, then every subsequent model state you create will have its own set of values for those sketches and those parameters. Not a big deal. You can go in there and fix it and type in the correct values. It's just more work. It's easier if you go ahead and configure everything the way it needs to be to start with. With assemblies, as you saw, suppressed components, they do not participate in the bill of material. So if the component is completely gone, the quantity is 0. And very easy to rectify that in the drawing mode just by turning off visibility of that row. A substitute model state balloons as a single part. So if you use substitution like we had in levels of detail, you have that in model states as well. That substitute, whether it's a derived assembly or a substitute piece part that you've modeled up, it'll represent and balloon as a single piece part, not as a subassembly. The vault gotcha. This is a pretty big one. Model state iProperty part number overrides, or actually any of the iProperty fields that you override, they are not searchable in Vault Basic or Vault Workgroup. What Vault will find is the master model state iProperty configuration. It'll find the information associated with that master, which is probably your generic that you started with. It will not index down and search the individual model state iProperty overrides. There is a way to set that up with Vault Professional by incorporating items. We can create an item and associate it to a model state, a particular model state with particular iProperty information and metadata. Drawings, one of the gotchas. The view name that you have, you cannot automatically retrieve the model state name and have that show up as the view name. It's not available as a piece of text you can just directly pull in like part number or description is. It's not there yet. It is one of the items that almost immediately made it to the wish list for whatever future version of Inventor may be coming down. Whether it makes it or not, we'll see. But it has been requested to have that. And I would guess it would be there because that seems like a pretty easy change to incorporate, but we'll see. As it stands right now, that name cannot be automatically retrieved. You just have to type it in. Assembly parts list, they default to show the 0 quantity. As you saw, you simply turn off visibility of that row, pretty quick and simple. Routed systems, this one was a bit of a surprise for just about everybody. If you use tube and pipe routing or cable and wire routing, in a level of detail for 21 and 20 and all the previous versions, you could create a level of detail and you could suppress an elbow that was inside of a pipe route. In 22, you cannot access that elbow. You cannot drill down in there and just suppress that one elbow. With model states for 22, it's the entire route or it's nothing. So you're limited to suppressing that entire route or that entire run, or you don't suppress anything. So what's next? Do you use model states or iParts or iAssemblies or view reps? How do you figure out which one to use? Well, luckily, Autodesk has created some pretty good resources. And if you want to write this down, you can go to the Inventor help and search for configurations and representations. This is in the Inventor 2022 help. and it outlines pretty well, you know, what they're talking about, the scope of it, how they work, things like that. But you drill down a little bit further and you get this table breakdown, and it shows you here's the tool and here's the purpose of the tool, and does it create a separate file, or you know, can you use it to manage certain things? Does it affect the graphics window? So right here, view reps. The purpose of it is visibility, state, color overrides, camera positions, and section views for sketches, dimensions, annotations, and work feature visibility. Position reps displays assemblies in different physical positions or states. So it's telling you what that purpose is. And right there for model states, create table-driven parts and assemblies in a single file. So up to that point, it sounds like an iPart until they say single file. With iParts, they generate table-driven parts and assemblies. Each member is stored in a separate file that can be managed and released. That's the other thing when you're working with Vault Workgroup or Vault Pro on a model state, you're releasing that IPT. You're not releasing that individual model state. You assume it's going to be released with it because of Vault Basic and Workgroup and Pro in the grand scheme do not access that individual model state of the piece part. You have to incorporate the use of items, which in that case, you're releasing the item associated with the file. So this is a pretty good table of information to help guide you of which one you might need to use. And again, all you do is in the Inventor help, search for configurations and representations. Pretty easy to find. There's also from Autodesk a what's new for 22 that specifically focuses on model states. So you're not getting any of the other what's new fluff. That's out there, but this one is focused purely on model states. Got a few overview videos, nothing in great detail to watch, but it does outline working with component families, flexible components, top-down simplifications, design options, bill of material data, things like that. Working in piece part mode, as well as working in family mode and assemblies, and getting down into drawings. A pretty good article to search for. And again, that's just the Inventor What's New 22 : model states. We'll take you to that one. So again, the question that comes up, will all of my levels of detail convert automatically? Yes, they will if they are supported. And that refers to the second line with routed systems. Because you cannot suppress individual components within a route using model states, the entire route would be suppressed with a model state. Can I use Vault with my model states? Yes, you can. But the iProperty information that you're going to be searching on will be that master iProperty. Obviously, there's ways to configure your metadata so that iProperty represents a family of components, and you can search for that family and find usage that way and where it's used and how it's used. But you will not be able to search on that individual model state iProperty. And now we'll open it up for any questions. Keith, how's it looking?
Looking pretty good. There was 2 questions that just came in fairly recently. How does this affect multi-bodied solids in a part file? And for sheet metal components, how does it affect the flat patterns?
Flat patterns, you're still configured, or you're still relegated to one flat pattern. The flat pattern will update based on whatever active model state is shown. As far as multi-body solids, it supports those. If you try to do a simplify, for example, you have the option to have an assembly simplified down to one part that has no face or no edges between the components. So all the planar edges are merged. You have the option of keeping the planar edges. You have the option of breaking down each individual piece part into a separate solid. So it is fully supported by multi-body solids. Any other questions?
No, I think you pretty much covered them all.
Okay. Give it just another minute. Make sure no other questions come rolling in. If you do happen to submit a question after we've ended the webinar, we will get those addressed as quickly as possible. that one that just came in, or did I see that one?
Yeah, new question just came in.
Okay. For some reason, I can't expand it.
It says level of detail properties used to be the same, but now they're independent. So anytime a revision is made, you must change all of the states, correct? I think that would basically just depend on what property changes you're trying to make.
Right.
If it was a global property that wasn't affected by the model states, then you would only change it in the master. But if it was a property that needed to be changed for individual pieces of the model states, then you'd have to dive into each one and make those adjustments.
And the key word there is the revision flag. Again, if you're incorporating Vault, it's not going to see the differences between those. It's all going to be self-contained in that one master IPT. It's simply your notations that's going to track that revision. Can iLogic be used to suppress zero quantity items in a parts list? I personally have not dove into that to see if iLogic touches it. I think iLogic will control visibility of a parts list row, but you have to know the row number ahead of time, if I remember right. Something I'll have to play around with to see what level of control we have. So I'm not quite sure on that one. Is there a limit to the number of model states you can create? Not that I have seen. There's no documentation from Autodesk that states that. And in learning this and just playing around with the various options, I think I got up to around 25 or 30 model states inside a one-piece part, and it didn't have any kind of problem with that.
Is this kind of in reference to the iPart limitation, where a component could have about 120 before it starts to choke Inventor? If so, I would imagine that the model states are going to handle the data much better, because it's not the same level of information. It's just a value change.
I would agree with that 100%. iParts and different configurations in iParts and iAssemblies. One thing I try to tell everybody is keep your number of configurations to 100 or less, and less if you can. If you need more than that, then break it up into individual configuration families. Model states, nothing wrong with following that same logic, but like Keith said, I don't think there's going to be the same kind of performance hit or performance limitation on it, because it's a much more simplified level of information. Can you lock the IDW? I think I need clarification on that one. If you're talking about locking the IDW view so that it doesn't update, is that what you're referring to? I don't know of any way to do that. The webinar will be recorded and will be available afterwards. I'm not sure how we share it with attendees. Ashley would be able to better answer that.
We'll send you an email tomorrow, which will have a link that you can watch it from.
How can you tell the difference between a global iProperty and a model state specific one? Well, if you click on iProperties, it's going to go to whichever model state is currently active. So if the master model state is active, the iProperties are going to reflect that. If you have a different model state that's active, the iProperties will reflect that one. So you have to just do a double check of which one you're working with. Can you reverse the right direction of a contour flange? Can't reverse the directions. The directions aren't controlled by the model states at all on any of the modeling features. What you would have to do is create the contour flange in direction 1 and create a model state for that, and then create a second model state suppressing the original contour flange and creating another one going in the other direction. All right, everyone, looks like that's it. If there's any questions that roll in afterwards, we will answer those offline, get to them as quick as we can. I want to say thank you for attending today's webinar. I hope you enjoyed it and hope you found it informative.